Hi, I'm Scott from RedmondPhysicsTutoring.com, and in this video I'll demonstrate how to solve for two unknown charges using Coulomb's law. Let's dive in. The problem describes 2 point charges 6 centimeters apart and says that each charge experiences a force of magnitude 88 newtons. It also tells me that the sum of these two charges is -9 microcoulombs and that the charges are attracted to each other. I need to use all of this to find the value of each charge in coulombs. Now, I always sketch it out and identify what's given and what's unknown, so I'll start by drawing the point charges, Q1 and Q2, and show that they're 6 centimeters apart. I'm not going to show the sign, positive or negative, of each charge yet. I'll add that soon. Alright, what's given? The Coulomb force magnitude is 88 newtons, and the charges add up to -9 microcoulombs. Since the charges are attracted to each other, they must have opposite signs. I'll arbitrarily choose Q1 negative and Q2 positive. What do I have to find? I have to find Q1 and Q2. I'll use Coulomb's law in terms of the force magnitude, and remember that the magnitude of a vector is always positive, so F12 is equal to K times Q1 times Q2 over R squared. In this problem, Q1 and Q2 have opposite signs because the forces attract, they're attracted to each other. When I look at the signs, I expect F12 to be positive, K is a positive constant, Q1 is negative, as chosen arbitrarily, but I need to stay consistent throughout the problem. Q2 is positive, and R is positive. Even without doing any math, I can see that, without the absolute bars, I have a positive on the left of the equation and a negative on the right. I don't know about you, but I prefer doing algebra without the absolute bars, so I'll add a negative sign on the right-hand side to make this equation correct for this problem, where the charges are attracted, and I've arbitrarily chosen Q1 to be negative and Q2 positive. Then I substitute in the values. 88 is equal to -8.99 times 10 to the power of 9, Q1 times Q2, over 0.06 squared, which I can simplify to 88 is equal to -2.497 times 10 to the power of 12 times Q1 times Q2. There are two unknowns, so I need another equation, which I get from the sum of the charges information. Q1 plus Q2 is equal to -9 times 10 to the -6. So Q1 is equal to -9 times 10 to the -6 minus Q2. I can substitute this into the previous equation to get 88 is equal to -2.497 times 10 to the power of 12 times -9 times 10 to the power of 6 minus Q2 times Q2. Then I expand and simplify down to a quadratic equation. 2.497 times 10 to the power of 12 times Q2 squared plus 22,475,000 Q2 minus 88 is equal to 0. Solving the quadratic gives Q2 is equal to 2.95 times 10 to the power of -6, or -1.195 times 10 to the -5. Now remember, I chose Q2 to be positive, so I take positive 2.95 times 10 to the power of 6 and substitute that into the equation for Q1, getting Q1 is equal to -11.95 times 10 to the -6. Therefore, Q1 is -11.95 microcoulombs and Q2 is positive 2.95 microcoulombs. Done. Now it's really easy to check this answer by substituting these into Coulomb's law, which gives 88 newtons. Yes. The trickiest thing about this problem is setting up the algebraic equations. The math doesn't know that Q1 is negative and Q2 is positive, so I need to build that information into the equation. There's actually a different convention for Coulomb's law, which writes it as a vector equation with r hat pointing away from the other charge. Then when both charges have the same sign, it represents a repulsive force, and when the charges have opposite signs, it represents an attractive force. Using that convention, I would need to put -88 on the left-hand side since the force is attractive and therefore in the opposite direction to r hat. I usually prefer to find the Coulomb force magnitude independently of the direction, and use understanding of charges and that opposites attract to get the direction, but this problem might actually be easier to understand when using the r hat convention. The choice is yours. You should use whatever makes more sense to you. I'm Scott Redmond, and I help students pass physics. If this video was helpful to you, please like it in YouTube to let me know.